When you tap an app icon on an iPhone, the app doesn't just launch. Before a single line of your code executes, iOS performs a trust check. It asks a very specific question. Is this app allowed to run on this device right now, under Apple's rules? If the answer is yes, the app opens instantly and you never notice the process. If the answer is no, the app simply doesn't run. There's no warning, no override, no "are you sure" dialogue. Execution stops cold. This is what app signing means on iOS. It's not just a requirement for publishing to the App Store. It's the foundation of the entire platform's security model. Every app, every update, every launch depends on cryptographic proof that the app is trusted by Apple. To understand how iOS app signing works, you have to understand Apple's core philosophy. Apple does not assume developers are trustworthy by default. Apple assumes the platform must enforce trust at all times, even if that creates friction for developers. That choice shapes everything about certificates, provisioning profiles, entitlements, and the publishing process. At a high level, app signing exists to answer three questions. Who created this app? Has it been modified, and is it allowed to run in this specific context? iOS answers all three using cryptography, backed by Apple as a central authority. When you build an iOS app, you don't just sign it with a private key the way you might on other platforms. You sign it using a certificate that Apple issued to you. That certificate is Apple's way of saying, "We know who you are and we're vouching for this code." Without that endorsement, iOS will not execute the app. This is the first major difference between iOS and Android. On Android, the operating system trusts that if the signature matches previous versions, the app is legitimate. On iOS, the operating system trusts Apple first. Your app runs because Apple allows it to run. That trust begins with certificates. An iOS certificate is not just a cryptographic key, it's a signed identity. When you create a certificate through the Apple Developer Portal, you generate a key pair locally on your machine. The private key stays with you. The public key is sent to Apple. Apple then signs that public key and issues a certificate that says, in effect, "This key belongs to this developer," and Apple recognizes it. That Apple signature is everything. iOS devices are hard-coded to trust Apple's root certificate authority. When your app is signed, the device verifies the chain of trust. It checks that your app was signed with a certificate. It checks that the certificate was issued by Apple. And it checks that the certificate is still valid and not revoked. If any link in that chain breaks, the app does not run. Certificates come in different types depending on what you're doing. Development certificates are used for building and testing apps locally. Distribution certificates are used for App Store builds. The distinction matters because it controls where and how the app is allowed to run. A development-signed app can run on specific devices you've registered. A distribution-signed app can run on user devices, but only through Apple's distribution channels. Certificates alone, however, are not enough. This is where provisioning profiles enter the picture. A provisioning profile is a configuration file that ties together several things: an app's identifier, a certificate, and a set of rules about where the app is allowed to run. During development, a provisioning profile explicitly lists which devices are allowed to install the app. That's why you can't just email an IPA file to someone and expect it to work. Their device isn't listed in the profile, so iOS refuses to run it. In production, provisioning profiles work differently. An App Store provisioning profile doesn't list individual devices. Instead, it says, "This app is allowed to run on any device as long as Apple has approved the distribution." The App Store becomes the gatekeeper. When you submit an app to the App Store, you are not just uploading code. You are asking Apple to validate that your signing, your certificate, your provisioning profile, and your app's declared capabilities all align. Only after Apple approves the app does it get re-signed for App Store distribution. This is a critical point that many developers misunderstand. The app users download from the App Store is not signed exactly the same way as the one you uploaded. Apple re-signs it. Users are trusting Apple's signature, not yours. Your certificate establishes authorship, but Apple's signature establishes permission. This is why Apple can remotely disable apps. If Apple revokes the distribution certificate or changes the trust status, devices will refuse to launch the app, even if it's already installed. That level of control is intentional. Apple designed the system so that trust can be withdrawn as quickly as it is granted. Now let's talk about entitlements, because this is where app signing becomes more than identity. Entitlements are capabilities. They are permissions that say what your app is allowed to do at the system level. Things like accessing iCloud, using push notifications, interacting with health data, running in the background, or using certain hardware features are not automatically granted. On iOS, permissions are not just runtime prompts. They are cryptographically enforced at signing time. Your app's entitlements are embedded into the signature. When the app runs, iOS compares the entitlements declared in the app with the entitlements granted by the provisioning profile and certificate. If there's a mismatch, the app fails to launch. This means you cannot simply enable a feature in code and expect it to work. The entitlement must be explicitly granted by Apple and included in the signing process. In some cases, entitlements require additional approval, such as special permissions for background execution, enterprise distribution, or sensitive APIs. This is why app signing errors on iOS can be so confusing. A single mismatch between entitlements, profiles, and certificates can prevent an app from installing or launching, even though the code itself is perfectly fine. Xcode hides much of this complexity, which is both a blessing and a curse. Automatic signing makes it easy to get started, but when something breaks, developers often have no idea what's actually happening. Under the hood, Xcode is generating certificates, managing provisioning profiles, syncing entitlements, and configuring build settings to ensure everything lines up. Understanding this machinery is the difference between being blocked for hours and fixing a signing issue in minutes. The reason Apple's system feels heavy is because it enforces security at multiple layers. Signing is checked at install time, it's checked at launch time, and it's enforced at runtime. If an app is modified after signing, the signature breaks. If the entitlements don't match, execution stops. If the certificate is revoked, the app becomes unusable. This approach dramatically reduces malware. It prevents unsigned code from running. It makes large-scale attacks difficult, and it allows Apple to respond quickly when something goes wrong. The trade-off is developer freedom. iOS developers give up control in exchange for platform guarantees. You cannot distribute arbitrary binaries. You cannot bypass the trust chain without jailbreaking. You cannot sideload apps in the traditional sense without special profiles or enterprise certificates, and Apple aggressively polices misuse of those mechanisms. From Apple's perspective, this is not a bug. It's the design. When you publish an iOS app, you are entering a managed ecosystem. You are agreeing to Apple's rules about identity, trust, and capability. App signing is how those rules are enforced technically. Once you see it that way, the system makes sense. Certificates establish who you are. Provisioning profiles establish where your app is allowed to run. Entitlements establish what your app is allowed to do, and Apple sits at the center, validating and enforcing all of it. App signing on iOS is not about convenience, it's about control. And that control is what allows millions of users to install apps without worrying about whether the code they're running is legitimate. If you're a developer, understanding this system doesn't just help you publish apps. It helps you reason about security, trust, and platform design at a deeper level. You stop seeing signing as a hurdle and start seeing it as infrastructure. Because on iOS, trust isn't implied. It's cryptographically proven every single time an app runs.